Let's look at the question, what is the simple interest on a loan of $30,000 for 1 year if the interest rate is 2.25%? For a question like this, we need to refer to our simple interest formula, which is I equals PRT, where I is the interest, what we want, P is the principal, the amount we start with, R is the rate, and T is time. Most of these we know already. For instance, time is 1 year, so it's going to be 1. And we're just going to put the appropriate numbers in the right spots. So, if I is equal to PRT, interest is what we want. We're starting with $30,000. Multiply that times our rate, which was 2.25%. Now, anytime we put in a rate, we want to make sure it's written as a decimal, not a percentage. So I would not put in 2.25 in here. I've been put in 0.0225, then times 1 year. And the reason is 2.25%. I need to change to a decimal, which means dividing by 100. And the effect of that is moving the decimal point once, twice to the left, which means I need a space filler, which I put my 0. So 0.0225. Once I have these, I'll put them into my calculator to find the amount of interest that I would earn, which in this case would be $675. And that would be my answer. Let's look at the question, if Sarah borrows $1,000 for 4 years at 13% annual simple interest rate, how much interest will Sarah pay? To do this problem, we want to look at our simple interest formula. I equals PRT, where I is the interest, what we want, P is the principal, what we start with, R is the rate, and T is time. Most of this we already know. We know what we start with, the initial amount, we know the rate, and we know the time. So it's simply a matter of putting the right numbers into the formula. So using my simple interest formula, I equals PRT, interest is what I want, principal is $1,000. The rate, we said, is 13%. Now rates in problems like this, when we put them into an equation, we want to put them in as decimals. We never want to put them in as percentages. It's going to throw off our answer. So we put in 0.13 because 13%, to translate to a decimal, we divide by 100. The effect of which is take the decimal point, which is currently right here after the 3, 2 spaces to the left, so hence the 0.13. T we set over the course of 4 years. Once we have this, it's a matter of putting the numbers into the equation and multiplying them out. And in this case, we get $520. So again, we do 1,000 times 0.13 times 4 to get $520, our total interest. Let's look at the question, what is the interest earned on an account with an initial investment of $12.50 at a 4.5% annual simple interest rate for 6 months? To find the interest, we want to use our simple interest formula, which is I equals P R times T, where I is the interest, P is principal, R is the rate, and T is time. And most of this we have. Remember, the principal is the amount that we start with, or the starting value of whatever you're either loaning or investing in. Rate is the rate, and time is whatever's given to us. Now, the problem like this, again, we know $12.50 is our principal, 4.5% is the rate, 6 months is the time. Now, what's unique about this is usually for our simple interest formula, time is usually given in terms of years. So in this case, it's given in terms of months. We want to convert it into years to make our equation work. First of all, we know what our principal is. It's going to be $12.50 our interest rate is 4.5%. Now in an equation like this, we want to insert it as a decimal. We never want to put it in as a percent. It throws the numbers way off. So 4.5%, to change to a decimal, I divide by 100. The effect of which means I move my decimal point twice to the left. And here I need a space filler. So this translates to the decimal, 0.045. Now for my time of 6 months, I need to convert that to years, so I need to think in 6 months out of 1 year, what is 6 divided by 12? That's going to be 1/2. So this is over the course of a half year, so we put in 0.5 for the time. And always, unless otherwise stated, we want to assume our time to be given in years with these kinds of problems. So when we multiply everything out, we'll end up with $28.125. Now this is a monetary value, so it only makes sense to have 2 decimal places. So I'm going to round to the nearest hundredth spot. So my 5 will be rounded up to a 3. So we'll say in this case, after 6 months, $28.13 is earned in simple interest. Let's look at the question. Sarah needs $15,000 for college in 6 years. If she invests $5,000 now, what simple annual rate is necessary for the investment to grow to $15,000 in 6 years? Since we're using simple annual rate, we'll use our simple interest formula. I equals PRT. I is our interest, P is the principal, R is the rate, and T is time. Time is given in years. Sarah needs $15,000, has $5,000 already. Using this formula, this gives us interest. However, it doesn't give us overall value. So what we need to do is think from 5,000 to 15,000. Using simple interest, meaning that we want the interest to add up to that new total. How much interest do we need? In other words, what's the difference from 15,000 to 5? That's going to be $10,000. So the interest we have, or the interest we want, is $10,000. We want $10,000 of interest. And the question is, how are we going to accomplish that? So using our formula, I equals PRT. Again, we want 15,000. We have 5,000. The difference is the interest that we want to make up. So 10,000 equals, we started with $5,000. The rate is what we don't know. We're trying to figure that out. And time is 6 years. So I put that in as well. So I've put in all the important information. And again, the annual interest rate is what we want. I can simplify my right side and say 5,000 times 6 will give me 30,000. So now I have 30,000 times R Solve for R. I'll divide each side by 30,000. So my R is equal to 10,000 over 30,000. And if I reduce, canceling my zeros, I'm left with 1/3. Now, I need it as a percentage. So as a percentage, if I divide 1 by 3, I'll get 0.333 repeating. As a percentage, I need to convert this by multiplying by 100. Now I have 33.3 repeating percent. And that would be my answer. So we say we'll need an interest rate of 33%, more specifically 33.3%, to gain that $10,000 in interest over 6 years. Let's look at the question. If the annual simple interest rate at a bank is 10%, how many years does Maria need to leave her $4,000 in the bank so that she doubles the value? Since we're talking about a simple interest rate at a bank, we need to use our simple interest formula, which is I equals PRT, I being interest, P being the principal, or what we start with, R is the rate, and T is time. So we've been given the initial amount, 4,000. We have our principal. We have the rate too. The question is, how many years does she need? So it's asking for time. Let's put in what we know. Principal was 4,000. Rate was 10%. Now in questions like this, we want our percentages to be entered in as decimals. You never enter these in, never put the percentage itself in this kind of problem. It will throw off your answers tremendously. 10%, I divide by 100 to make it into a decimal. The effect is this decimal point moves 2 spaces to the left. So 0.1 or 0.10. That's my decimal. Time is what we're trying to figure out. How long will it take? Now it says till her investment doubles. So in other words, she wants to have $8,000. Now we can only calculate interest, so we have to consider how much interest does it take, or do we add on to 4,000 so that we double the value? Well, what's double the value of 4,000? It's 8,000. Which means we want the interest here to total $4,000, because that would allow us to double the initial amount. So what we're trying to figure out is, and here's our time, what value for t, what value for time allows us to make $4,000 in interest. Simplifying my right side, I'll make this 400 times t. And to solve for t, I'll divide each side by 400. I can reduce my left side. My pairs of zeros can cancel out. Now I'm left with 40 over 4, which I will reduce to 10. So specifically, I need to say this tells me that 10 years will need to pass before I can double the initial investment, or Maria can double her initial investment, going at this rate. Let's look at the question. Leroy buys a $1,200 computer. Store gives him credit using simple interest at 20% over 2 years. How much does Leroy pay for his computer? With questions like these, we're looking at the total amount paid as opposed to just interest. Even though we're using simple interest, we're going to use a slightly modified formula. So, if we're calculating total cost as opposed to just interest, we have two possibilities for formulas: A equals P plus I, or A equals P plus PRT. They're the same formulas, except in the one on the left, I simply represents interest, or the one on the right spells it out from the original equation, I equals PRT. Either one is valid. You're doing the same amount of work either way. P is still principal, R is still rate, and T is still time. So I first need to figure out what is the interest that's being charged to him over these 2 years on this purchase. Then, since that has to be paid, I add that back onto the original amount that he paid for the computer. That becomes our total cost. So I can say amounts equal to P plus PRT. My principal I know is $1,200. My rate was 20%, and my time was 2 years. So to find out my total cost, I need to figure out first the interest that Leroy accrued over this 2-year period of time. Interest meaning, in this case, what he has to pay in addition to the original value of his computer. So put in our values. 1,200 times the rate. With rate, we want to change our percentage into decimals. We never want to put a percentage in a number in percent form into an equation like this for rate. Always change it to a decimal point, which means I'll divide by 100, taking the decimal point and moving it 2 spaces to the left. So the rate that I actually want is, or R that I actually want is 0.2. T is 2 years, so that's 2. This other P for principal is still my 1,200. So again, in the first part of this expression, I'm just putting in my principal as was given to me. In the second part, I'm figuring out the interest on that investment. Just the interest. So when I multiply the numbers out, I'll end up with 1,200 plus 480. So this means Leroy is going to accrue $480 worth of interest. I need to add that onto the amount he paid for the computer to get the total cost. So 1,200 plus 480 gives me $1,680.
Credit cards and simple interest. The annual percentage rate is the annual interest rate associated with the credit card. The period is the length of time used to calculate the balance, usually 365 days. Purchases are charges on a credit card from purchasing goods and services. The average daily balance is used as the principal when computing simple interest on a credit card. Use the following credit card statement to determine the amount of interest for the given statement period. As you can see, the annual percentage rate is 23%. The average daily balance is $215.48. We are given the statement period, which is December 15th through January 14th. What is the amount of interest for this period? We will use the formula I equals P R T, where I is the interest, P is the average daily balance. And the average daily balance on the credit card was $215.48. The rate is our annual percentage rate given on the credit card, which is 23%. Changing that to a decimal, we get 0.23. T, which is equal to the number of days in the period divided by the number of days in a year, which is 365. We need to figure out the number of days in this period. This period is from December 15th to January 14th. In December, we will go from the 15th of December to the 31st of December, because there's 31 days in December, for a total of 17 days. And then we'll add to that the days in January on this period, which are the 1st of January to the 14th of January, which is 14 days, for a total of 31 days. So our time will be calculated as 31 divided by 365. So plugging all this in to our interest formula, I equals P, which is 215.48, times our rate in decimal form, 0.23, times our time, which is 31 divided by 365. We'll use a calculator and calculate this to be 4.209. Because we are working with money, we will round to 2 decimal places, and that gives us $4.21.